Hi, I'm Anjana Vakil, software developer and developer advocate at Observable. I'm really excited to take you all along with me on a journey through some functional JavaScript first steps. I created this course because functional programming can be really exciting and really interesting, but it can also be really scary and intimidating to get started with. So I hope that this course will provide a friendly, gentle introduction into some of the core concepts of functional programming so that we can continue learning more and more about this fascinating programming paradigm. In this course, we'll learn how functional programming boils down to the key idea of doing everything with pure functions. We'll learn techniques for using things like recursion and higher order functions to replace the iterative loops we're used to writing with for and while. We'll learn about closures, currying, function composition. We'll also talk about why immutable data is really helpful for functional programming. I really hope you enjoy this course, and I hope it puts you in great position to go on and continue your functional programming journey with other awesome courses on Frontend Masters. So we are now wondering, how do we go about functional programming? Well, again, the core idea is that we use pure functions. But what does this mean? What mantra should I have as a functional programmer to repeat to myself to remind myself how to do functional programming? Well, that's what we're going to be talking about the rest of the day. And there are a few kind of guiding principles that we're going to get into in the different sections and the different exercises that we work through. But here are a couple of the main things. Number one, we have to do everything with functions. Our program becomes a function. So instead of thinking, again, about a program as like an imperative series of commands, of we have to do this and then do that and then do the other thing, we can start thinking about our programs as a function. What are the inputs to my function? What are the outputs? So this requires us to think about our programs a little bit more differently. Instead of thinking, how should my program run? Which is a pretty imperative question to be asking ourselves. We should be asking ourselves, what should my program take in, and what should my program return out? Again, this is all a consequence of doing everything with pure functions. So let's take again a look at a couple of versions of a program. On the imperative side, we have a series of commands. Store this string in this variable. Log this to the console. Update this variable with this other string. Log that thing to the console. Imperative commands. What are the inputs? What are the outputs? I know we're not really asking ourselves those questions in the imperative style. But in the functional style, our program here is this single function, this greet function that we're looking at. And the program takes in two key inputs: the greeting that you want to use and the name of the person that you're greeting. And the output is going to be this "Hi, Alonzo," or "Howdy, Alan" response, this string. So we're now thinking about, we have a program, a really tiny, small little program, but a program for greeting people. We're thinking about, what are its inputs? A greeting and a name. What is its outputs? A string. And so this is what we're going to end up doing in the functional programming style, is thinking about our programs as functions that take inputs and return outputs. So this means functional programs are a really great fit for things like, again, data transformation, where you know what type of thing is coming in and you know what thing you want to come out. That is a really great use case for thinking about your code in terms of pure functions. So what this lets us do is it lets us take a function which takes multiple arguments and kind of lock in some of the values. Another way of saying this is it lets us partially apply a function. Apply in the functional programming world is kind of a word like call a function. And so partial application is this notion of kind of remembering certain arguments and being able to then reuse functions more easily because I don't have to keep passing in the same value over and over again. Cool, 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 cool. There's a related concept in functional programming called currying. Currying is the process of taking a multi-argument function, a function that takes in multiple values as its input arguments, and breaking it up, in a sense, into a series of single argument functions which successively remember the outer scope so that I can partially apply each of those multiple arguments to create, again, more reusable functions that I can use to create more complex programs out of simple functions. Let's take a look at some code, because me yapping is not going to help this set in very well. All right, here I've got my old greet function, if you remember from earlier, which takes in a greeting and a name and returns out, "Hi, Alan," or "Howdy, Alonzo." Now what I'm doing is I'm making a curried version of that greet function, which I'll call curry greet, which is a single argument function. It takes in a greeting. Then it returns another single argument function, which takes in the name and returns the same result as our original greet function did. So now, if I want to greet lots of people with the same greeting, I don't have to keep passing in that greeting over and over and over again. I can create a new function, like a greet Italian sort of function, that I'm going to create by calling curry greet on the greeting that I want to use, like ciao. And now I have a function that I can call on anybody's name, and because of closure, this inner function remembers that ciao, that greeting, and is going to be able to output the desired string even though I didn't have to keep passing ciao in. And so similarly, we can see it again in this example. I can create like a Texan greeting by passing howdy to my curry greet. And now I can greet all kinds of people with my howdy greeting without needing to repeat myself and keep passing in that same greeting argument over and over and over again. So these concepts kind of go hand in hand. Closure being the concept through which that inner function can remember the outer function's scope. And currying being the process of taking that multi-arg function and breaking it down into a series of single argument functions, which, thanks to closure, allow me to partially apply that multi-argument function and create a version that remembers the first argument I passed in and gives me a new function I can call on the second argument. So these are a series of concepts that kind of go hand in hand to allow us to make more modular functions. They allow us to break down complex functions in a way into sort of little Lego blocks that we can then build up together into other complex functions. So these are some of these concepts that when you get really into the functional programming world, they're going to start to become second nature. But for now, they might feel a little bit strange. And it also might look a little bit strange because sometimes we'll have like a lot of functions successively calling arguments one after the other instead of passing in all those arguments to a single call to the function. But if we can wrap our heads around this, we'll be in great shape to go on and understand some of the more in-depth ways that we can work with closures and currying and partial application in more intermediate or advanced functional programming courses or tutorials or things like that. What ends up happening when you write functional programs is that you end up writing programs where you think about how the data is going to flow through your different functions. So you end up with something like this, where if I want to get from A, a green circle, to B, a purple triangle, I might think, okay, I could have a function where I'm going to transform green circles into triangles. And then I might have a function where I'm going to transform the color and return the same shape but purple. And so we're going to be flowing data through. So we think, what's the output that I want? What's the input that I'm getting? And how can I flow the data through a series of functions to get the result that I want? And once I figure that out, I can actually use something called function composition, where we sort of putting together functions, composing them together, to take simple functions and create complex programs that nevertheless themselves are input in, output out functions. So what this might look like is if I had that f of x function, which is turning circles into triangles, and then I have a g of x function, which is turning green into purple, what I actually want to be doing is calling them both on the same input. So first I'm going to call f of x, and then whatever the output of that is, I'm going to call g on that. And what I get then is kind of, I can make a single function that does all of that. So now I can treat that outer function as just a black box, and once I've got it composed the right way, I don't need to worry about all of the minuscule little operations that are happening inside of it. I can treat it as a single kind of black box where I only care about the input coming in and I only care about the output coming out. So for example, I have a little ender function here, which is similar to the curried function we saw before, where it takes in a single argument, returns another function that takes in a single argument, and then smushes their values together. So I can make an ender function that I'll call adore, which is going to say that something rocks. And then I might make an announce function that's going to say that something, y'all, like, hey, y'all. And then I might make an exclaim function, which is going to end things with exclamation point so that I'm really excited about it. Now, I probably don't think each of these are super useful on their own, but I could put them all together into a function that I might call hype up, where I take in some thing, some value x, string in this case, and then what I'm going to do is say that I adore it, say that it rocks, announce that, say, hey, y'all, and then exclaim that. So add an exclamation point so that you know that I'm really hyped up about it. So if I hype up JS, I can say, JS rocks, y'all, woo! And if I hype up FP, I say, FP rocks, y'all, really excited, huh? And hopefully by now, in this long brain-busting day, we're all feeling super hyped about this functional programming stuff.